Hello students, welcome to the class of physics. This is your lecture number 3 of chapter thermodynamics. In the last lecture we have seen what is first law of thermodynamics, what are the conditions for positive, negative and zero internal energy. In that we have seen what is the expression we are getting by applying the first law of thermodynamics, that is gives the relation between heat and work done. And we have seen what is the meaning of negative work done by a system and what is the meaning of positive work done by a system. Then we have derived an expression for amount of work done in changing the volume of a sphere, and the final expression which we got is W is equals to, that is work done is equals to P delta V, that is P is the pressure, delta V is the change in the volume. That is internal energy of a system can be changed by doing some work on it. And it gives the amount of work done in changing the volume of a system. Then we have seen what is the condition for positive, negative and zero internal energy. Now today we'll start with what is thermodynamic process. Like we have seen what is thermodynamic state variable, what are thermodynamics equilibrium, we have seen mechanical, chemical and thermal equilibrium. Now based on that, today we'll see what is the meaning of thermodynamic process. Now thermodynamic process is what? Thermodynamic process is a procedure by which the initial state of a system changes to its final state, in which, so in simple word, just there is a change of state from initial to the final state. So during such a change there may be a transfer of heat into the system from its environment, that is positive heat. For example, when we boil a water, what happens when we boil a water? Heat is transferred to water, and that heat may be released from the system to its environment. So when heat is released from the system to environment, it's a negative heat, and when heat into the system, that is the positive heat. When heat released from the system to its environment, that is the negative heat. Similarly, some work can be done by the system, that is positive work, or some work can be done on the system. If work is done by the system, that work is termed as what? Positive work. And if work is done on the system, that work is referred as what? Negative work. And the best example for negative work is when the piston in a cylinder is pushed in, some work is done on the system. So we know that these changes should occur in a very short period of time, so that system is always in a thermodynamics equilibrium. What is the meaning of thermodynamics? There is a no exchange of heat, that is they are at constant temperature. Such process in which changes in the state variable of a system occur infinitesimal slowly, that is state variable is the pressure, volume, occur infinitesimal slowly, are called quasi-static states. So thermodynamics is nothing but what? It is just a procedure in which there is a change of a system from initial state of a system changes to final state, or in other words we can say that a process by which two or more of state variable of a system can be changed. Two or more state of a variable can be changed and is called thermodynamic process or thermodynamic change. Now, state of a thermodynamic system can be changed by interacting with its surrounding through work and heat. When these changes occur in a system, it is said that the system is undergoing a process. And when such process in which changes in the state variable of a system occur very slow, very infinitesimal slowly, are called quasi-static system. So, when a thermodynamic system changes from initial states to its final state, it passes through a series of intermediate states. ऐसा नहीं कि direct change हो जाएगा. There is some steps, some phase. So, it passes through a series of intermediate states. This series of intermediate states when plotted on a PV diagram is called path. In the last lecture I have told you what is the meaning of PV diagram. What is PV diagram? PV diagram is nothing but what? It is the graphical representation of equation of state of a system of gas. Graphical representation of equation of state of system of a gas is called PV diagram, or the PV curve, or the indicator diagram of the system. Okay, so when this intermediate state are plotted on a PV diagram, that intermediate state, series of intermediate state is called as what? Path. And the PV curve or the PV diagram is such a path. It tells, and that path tells us the way a system has gone through a change. The path tells us the change the system has gone through a change. So what is PV diagram? When a thermodynamic system changes from its initial state to final state, it passes through a series of intermediate states. And this series of intermediate states, when plotted on a PV diagram, is called a path. And the path tells us the way a system has gone through a change. Means by observing a path, we can know how the changes has occurred. Which change has, whether it is a positive change, whether it is a negative change, which kind of change, whether it is a pressure and volume changes or only volume changes. So by just observing the path, we can come to know कि जो चेंज हुआ है प्रेशर एंड वॉल्यूम दोनों में हुआ है, और ओनली वॉल्यूम चेंज हो रहा है या ओनली प्रेशर चेंज हो रहा है. सो दैट पाथ टेल्स द चेंज इन द सिस्टम, अबाउट द चेंज इन द सिस्टम. सो वन बाय वन विल सी हाउ द चेंजेस occur. So work done, it is work done during a thermodynamic process. Now this diagram shows the PV diagram indicating change of state of a system from initial state. Here for initial state, for volume we have taken VI, and for pressure we have taken PI, to final state VF and PF along different possible path. Now consider a system. Now let's understand what is the relation between path and the work done along a path. Now consider in this diagram, we will see diagram number A, which shows the different way to change a system. Here 1, 2 and 3 different paths is shown in the diagram, that PV diagram. The system is initially at state A on the PV diagram. Its pressure is PI and the volume is VI. Now B says that the system is indicated by the coordinate. Now this is the path 1. It is shown pressure PI and the volume is VI. And what will be its coordinate? Coordinate will be VI and PI. Now the final state of a system is shown by the point B. This is the initial state A and its coordinate is VI and PI. And the final state is shown by the point B and its coordinate is VF and PF, that is final volume and final pressure. Now the curve 1, this path 1 shows in figure, is one of the many ways in which we can change the system from state A to state B. When the system changes itself from point A to point B along the path 1, both its pressure and the volume, both is changing. Now when we take only path 1, in this diagram we have shown all the possible way system can change, path 1, path 2 and path 3, where for initial state we have taken VI and PI, for final state VF and PF. Initial point is A, final point is B. Initially they will start from here only and finally they have to reach point B only. But there are the different way. These are the path. Now if we take the path 1, in path 1, when system changes from point A to point B, there is a change in both its pressure and the volume. Both changes, pressure and the volume both is changing. Now the pressure decreases while the volume increases. In this case, initial volume Vi change हुआ, volume increase हुआ, and at the same time pressure is decreasing. Pressure is decreasing. Now the work done by the system is positive. In this case, work done is positive. Why positive? Because the volume increase हो रहा है. The volume का value increase हुआ, pressure decrease हुआ. So in this case, the work done is positive. So it is given by the area under the curve. The work done is given by this area under the curve. Now the second way is what? To change the state from A to state B. It's path 2. Second way is path 2. Now in this case, the volume increases to Vf from the point A up to the point C. In this case, volume increases from Vi to Vf up to the point C at the constant pressure. Here pressure is constant. Now the pressure then decreases to Pf. Pressure is constant and then pressure is decreases to Pf. The volume remains constant during this change. Now the system is now in the state B with its coordinate is given by Vf and Pf. Vf and Pf. Now the work done in this process is represented by the shaded area under the curve. Here in this case, volume is constant and pressure is decreases. Volume constant है but pressure is decreases from Pi to Pf. Now work done in this process is represented by this shaded area. Now third way to change the state from state A to state B is path 3. In this case, the pressure decreases. In this case, the pressure decreases from Pi to Pa, but the volume remain the same. The volume remain the same. Now volume changes to Vf at constant pressure. The work done in process is represented by again the shaded area. So it is easily noticed that in these three cases we discuss the amount of work done is not the same. Say in all these three cases, this shaded area shows the work done, here also shaded area shows the work done, and here also shaded area shows the work done. And in all the three cases we can see the amount of work done is not same. Here pressure and volume both change हो रहा है. In the first case, the volume changes at constant pressure and then the pressure changes at constant volume. And in the first, the pressure drop at constant volume and the volume changes at constant pressure. So here this is the shaded area, the work done. This is the shaded area, the work done, and this one is the shaded area, the work done. So in all these three cases, the work done and the amount of work done is not same. So these are only three parts amongst many along with the system can change its state. So it is very interesting to note that in all these cases, though work done during the change of state is different, the initial and the final state of the system is same. The amount of work done is different, but the initial and the final state of the system is same. So what we can conclude that from this, the work done by a system depends not only on the initial and final state but also on the intermediate state, that is on the path along which the change takes place. So we can say that in the first diagram, that is first case, when the system changes itself from A to B, both its pressure and volume changes. The pressure decreases while volume increases. So the work done by the system is given by the area under the curve, and it is positive when the volume increases. Now in the second case, again changes from A to B. In this case, the volume increases to Vi from point from the point A up to the point C at the constant pressure Pi. From the point A up to the constant pressure C at pressure Pi. Now after point C, the pressure of the system decreases to Pf. The pressure of the system क्या हो गया? Decrease हो गया at constant volume. So the system thus reaches its final state B with coordinate Vf and Pf. The work done in this process is again represented by the shaded area. Now third case, in this case the pressure decreases from Pi to Pf at constant volume. Pressure decreases from Pi to Pf at constant volume along the path A, this path. Now from this point, the volume of the system increases to Vf at constant pressure. So work done in this process is represented by again the shaded area. So from all these three figures, we can conclude that the work done is more when the system follows path A, C and B. That is, when it follows this path A, C and B, the work done is more. The work done by the system is more than the work done by this path. Now we will see heat added during a thermodynamic process. What will happen when heat is added during a thermodynamic process? Now, as we know, thermodynamic state of a system can be changed by adding heat. Now, consider a thermodynamic system consists of an ideal gas confined to a cylinder of volume and having a movable frictionless massless piston. Suppose we want to change the initial state from Vi to Vf. Here we are applying a heat to change the system. Now we have to just consider the system consists of an ideal gas which is confined to a cylinder which has a movable frictionless massless piston. Suppose we want to change the pressure from Vi to Vf at constant temperature. So when the gas is heated slowly in a controlled manner, it expands at a constant temperature. It reaches the final volume Vf isothermally. We will see in detail what is the meaning of isothermally. Now in short I will tell iso means same, thermal temperature, same temperature, constant temperature. Isothermal means constant temperature. So it changes isothermally. So the system absorbs a finite amount of heat during this process. But as the process is very slow, the temperature remains constant. So in this way, the gas expands and reaches final volume Vf at constant temperature. So there are two different ways in which the change in volume can be made. In first one, in volume can be made. First method is this case, the gas is heated slowly in a controlled manner so that it expands at a constant temperature. It reaches the final volume Vf isothermally. And the system absorbs a finite amount of heat during this process. And in the second case, gas cylinder is now surrounded by an insulated material and it is divided into two compartments by a thin breakable partition. Now the compartment X has a volume Vi and the compartment Y has a volume Yi. So that Vi plus V dash I is equals to what? Is the final volume. It is divided into two compartments. Initial volume Vi, final and this two compartment X and Y. The volume of X is Vi and the volume of Y is Vi dash. And what will be the final volume? Vf will be Vi plus Vi dash. Now the compartment X of the cylinder is filled with the same amount of gas at the same temperature as that in the first case. Whatever amount was gas is filled in this case, the same amount of gas is filled over here. And the compartment Y is empty. It contains no gas particle or any other form of matter. Now, the initial state of a system is same in both the case. Initial state is same here also and here also in both the case. Now, the partition is now suddenly broken. This caused a sudden uncontrolled expansion of the volume of the gas. Here there is a sudden Now the partition is now suddenly broken. Partition is now suddenly broken. This caused a sudden uncontrolled expansion of the volume of the gas. Now the gas occupies the volume that was empty before the partition is broken. So there is no exchange of heat between the gas and its environment because the cylinder is surrounded by an insulating material. So the final volume of the system after the partition is broken is Vf. So in this case, the gas has not done any work during its expansion because it has not pushed any piston or any other surface for its expansion. So such expansion is called as what? In this case, there is no piston. किसी ने भी गैस को पुश नहीं किया है. We have not heated the gas. Then too suddenly there is a compartment broke and there is a expansion of the gas. So this sudden expansion or such expansion of gas is called as what? Free expansion. And the best example of this free expansion is abrupt puncturing of an inflated balloon or a tire. So it is experimentally observed that when an ideal gas undergo a free expansion, there is no change of temperature. Therefore, the final state of the gas in this case also is the same as the first case. Now, the intermediate state or the part during the change of state in the first and the second state are different. In both the case, the intermediate state or the path of changing the system is different. But the initial and the final state are same in both the case. So, these two represents this two figure represents one it is heating and one where we have insulated the these two states what indicates different path connecting the same initial and the final state of the system. So this two represents two different way of taking a system from the initial state to the final state. Okay, so in case of the method there is an exchange of heat. In the first case where we have heating, there is an exchange of heat, and in the second case there is no exchange of heat, and the system does not do any work at all because there is no displacement of any piston or any other surface. So what we can conclude that the heat transferred to a system also depends on the path. It also depends on the path. Now we'll see for numericals whatever topic we have covered till now. So the first numerical is a gas contained in a cylinder fitted with a frictionless piston expand against a constant external pressure of 1 atmosphere from a volume of 5 liter to a volume of 10 liter. In doing so, it absorbs 400 joule of thermal energy from its surrounding. Now determine the change in internal energy of the system. So here we will use first law of thermodynamics, that is the amount of heat supplied is used in doing some work and change in the internal energy, and the expression is given as Q is equals to delta U plus W, where Q is the amount of heat supplied, delta U is the change in the internal energy, and W is the amount of work done. Now we have to find change in internal energy, so we'll take delta U on left side, and on the right side it will be Q minus W. Now what is given? First we will write, for it is given pressure which is 1 atmosphere, and 1 atmosphere it's a constant, it is 1.0132 10 to the power 5 Newton per meter square. Now initial volume it is given 5 liter. to a volume of 10 liter. So VI, initial volume is 5 liter. So 5 into 10 to the power minus 3 meter cube. And the final volume is 10 liter, which is 10 into 10 to the power minus 3 meter cube. And the amount of heat in doing so absorb how much heat? 400 joule of thermal energy from its surrounding. So what is work done? It is P delta V. P delta V is nothing but what? It is Vf minus Vi. So W will be P, we know 1.01325 10 to the power 5. Vf 10 minus 5 10 to the power minus 3. So it will be 1.01325 into 500. This 10 to the power 5, 10 to the power minus 3 will be 10 to the power 2. 10 minus 5 is 5. So 5 into 10 to the power 2 will be 500. So when you will multiply this 1.01325 into 500, you will get 506.65 joule. So we'll substitute delta U will be Q, we know it is 400, and work done is 506.65. The answer is coming in minus, that is 106.65 joule. So here negative sign indicates decrease in the internal energy. Negative sign indicates what? Decrease in the internal energy. I hope it is clear. Now next we'll see. Next numerical. A system release 125 kilojoule of heat while 104 kilojoule of work is done on this system. Now calculate the change in internal energy. So here again Q is given. System release, when system release heat, it is minus 125 kilojoule, while 10 kilo work is done on the system. Work is done by the system, then it is positive. Here work is done on the system, so work done is also negative. It is minus 10. Heat is released, system release heat 125, which is negative, and work is done on the system, that is minus. So what will be the change in internal energy? So again we'll use first law of thermodynamics, the same formula. Delta U is Q minus W. We know Q, it is minus 125, and W minus of minus. So we are getting was 21 kilojoule. It is 21 kilojoule. Again the negative sign indicates for there is a decrease in the internal energy. So change in internal energy is 21 kilojoule, and the negative sign is nothing but what? It shows that change in the internal energy decreased. Now next topic is what? Classification of thermodynamic process. Now this thermodynamic classification, there are various processes: reversible and irreversible process, isothermal process, isobaric process, isochoric process, and adiabatic process. Here reversible and irreversible process is just I'll tell the definition. Reversible process is a change that can be retraced in a reverse direction, and irreversible process is a change that cannot be retraced in reverse direction. That is opposite. Reverse direction is nothing but what? Related with the opposite direction. Okay. Isothermal is something which is related with the constant temperature, and isobaric process is nothing but what? Which is related with the constant pressure. Isochoric process, volume constant or composition constant. Adiabatic is the pressure constant, or no, it is the amount of heat which is there is a no exchange, that is adiabatic. So I hope it is clear to you all over here. In the next lecture we will see in detail what is the meaning of isothermal, what is the meaning of isobaric, and what is adiabatic process. Adiabatic process is the process during which there is a no transfer of heat from or to the system. Heat transfer Q is 0. Isochoric is system does not do any work, and all the energy supplied to the system is converted into its internal energy. So for an isochoric process, delta V is constant. For an adiabatic process, Q is 0, or we can say constant, no exchange of heat. For isobaric process, delta P is 0, and for isothermal process, delta T is 0. So in the next lecture we will see in detail what is the expression for heat in terms of isobaric, isochoric, adiabatic and isothermal. So I hope it is clear you all till here. So what we have completed today we see what is the meaning of thermodynamic process, how the system changes from initial state to the final state without change in its variable. So in the state variable of system change, that is called thermodynamic change, and the change in the state of variable system occur very slowly, called quasi-static process. It's a very slow process, and here with the help of PV diagram we can express the path, and that path tells us a system has gone which gone through a change. So series this path has a series of intermediate states. So here the different in the first diagram we have shown all 1, 2 and 3. So this path 1, decrease in the pressure, volume increases, both pressure and volume changes, work done is positive. In the second, first the volume changes at constant pressure and then the pressure changes at constant volume. So here both pressure and the volume both is changing, and here first the pressure drops at a constant volume and then volume increases at a constant pressure. So these are the three methods, but in all the three conditions the initial and the final state are the same. That is, initial state is A and the final state we are getting B. Only the path is different to reach the initial and the final state, and the amount of work done is also different. Here the shaded area shows the amount of work done, here the shaded area shows the amount of work done, and here the more work done has been done over here in A part A, C and B, and here second, and this is the least work done, amount of work done is least in this condition. Now what will happen when a heat added during a thermodynamic process? So we have seen when you supply a heat there will be a change in the system. Heat system does work on the piston, and in this case work done is positive, heat is supplied and that is positive. And in the second case there is a sudden uncontrolled expansion of gas, no heat enters system, does no work, so work is 0, Q is 0, but initial and the final state is same. Next we have seen two numerical based on the first law of thermodynamics, and these are the classification: reversible, irreversible, isothermal, isobaric, isochoric and adiabatic. In next lecture we will see in detail what is the meaning of reversible and irreversible, what is isothermal, what is isobaric, what is isochoric and adiabatic process. So I hope it is clear to you all.